Hi, Assalamualaikum. I want to introduce about our project that is given to us. Our project title is about the bus arrival at bus stop at ATM in front of the DTMI hall and in front of UTHM stadium. We decide to use three types of buses, which is from College Kediaman Bestari, College Kediaman Purwira, and College Kediaman Tun Dr. Ismail / Tun Fatimah. Those buses has their own schedule that determined by PPA, which is every day, and we use the peak hour, which is early morning and evening. So we decided to take the data for 2 days, 1 hour for each days and 15 minutes intervals for three types of buses.
Assalamualaikum warahmatullahi wabarakatuh. So I want to share about the methodology for this project, which is number one is identifying list of variable. The second one is collecting data at the ATM bus stop, and number three is confirming all of the data, and fourth is identifying the formula from the ANOVA method, and five, we calculate using the advanced statistic, which is using the ANOVA test method, and lastly interpret the output and analysis the output. Thank you.
Wabarakatuh. My name is Muhammad Amirul Hakimi bin Muhammad Hussein. Okay, now I want to talk about data presentation. First of all, we have prepared this table to collect the bus data assigned to each group members. Okay, this table is every 15 minutes. Okay, this table is to collect bus from College Kediaman Tun Fatimah and Tun Dr. Ismail. Okay. The next table is College Kediaman Perwira bus College Perwira. Okay, then the last table is College Kediaman Bestari. Okay, that's all. We have two data from each residential college bus, the first and second day. Data was restricted from 15 minutes to 1 hour. Both data were first and second day achieving balance in the graph table. College Kediaman Perwira, table D1 and D2 is balanced. College Kediaman Tun Fatimah and Tun Dr. Ismail, D1 and D2 is balanced. Okay, that's all.
For day 1, location ATM bus stop, date 25 November 2019, time 7 a.m. to 6 p.m. For discrete analysis, we have time class, midpoint, frequency, fx, x square, fx square, fx square. And for summation of frequency, 161, fx 2004.5, x square 2171, fx square 27,218.25, fx square 355,459.75. For the mean, we have 12.45, mode 8.5, and median 11. For the variance, we have 156.32, Standard deviation 12.5. This table of midpoint, cumulative and cumulative percentage. And this is the graph cumulative percentage against midpoint. For differential statistic, which is one-way ANOVA test, this table type of bus, Bestari, Perwira, TF or TDI. So we have data here for day 1 from 7 a.m. to 6 p.m. So for H now, the mean bus are all equal. H alternative, the mean bus are not all equal. We use significant level is 0.05. Degree of freedom in the numerator V1 is K minus 1. So we have K 3. So K minus 1 equal to 2. Degree of freedom in the numerator V2 is N minus K. So N we have 36 minus K 3. So equal 33. The F distribution for this test is one tail. So we use significant level 0.05. Therefore, from the critical F table, the critical F value is 3.30. Decision rule: if calculated F bigger or equal critical F value, we reject H now. So this table show F distribution critical value. So for V1 is 2, V2 is 33. So we got 3.32. This table that we calculate TC, NC, TC square over NC and X square. So the total for TC 161, NC 36, TC square over NC 791.08 and X square 921. So this is a calculation for SS 200.797, SST 71.05. So SSE, SS minus SST 129.92. So for F we got 9.02. So this is ANOVA table. For sum of square treatment 71.05, error 129.92 and total 297. For degree of freedom, treatment is 2, error 33, so total 35. Mean square 35.53 for treatment and 3.94 for error. And for F, we got 9.02. Since the calculate F 9.02 is greater than the critical F, which is 3.32, we reject H now. Therefore, we accept H alternative. We state that the population mean are not all equal. Thank you.
This is the discrete data for day 2. The total frequency of the buses in day 2 is 160 buses. And then we will find each of this column and then we will total up everything. We will find the mean, mode, median, standard deviation and variance. So for the mean of day 2 is 12.32. Mode is 8.5. Median is 11.73, variance 151.62, standard deviation is 12.33. So we will get the graph like this. Cumulative percentage against midpoint. The graph is increasing constantly. Differential statistic, we use one-way ANOVA test. This is the data collected for day 2. Bestari, Pewira, TF, TDI. H note, the mean buses are equal. HA, the mean buses are not equal. The significant level alpha is 0.05. Degrees of freedom in the numerator V1 is k minus by 1, then we get 2. Degrees of freedom in numerator V2 is n minus by k, and then we get 33. Therefore, from the critical F table, the critical F value is 30.3.32. So this is how we get the F critical. Since the V1 is 2 and then the V2 is 33, then we will get 3.32. Decision rule. If calculated F more than or equal critical F value, we will reject H note. From this data, we will get the TC, NC, TC square over NC, and X square. We will apply the formula and then we will get the F. So, since the calculated F 7.18 is greater than critical F 3.32, we reject H naught. Therefore, we accept HA, which states that the population means are not equal.
Wabarakatuh. For the discussion for this project is we has been collecting and analyzing the data by using one-way ANOVA. Operation has been compared beside the dependent variable. Is measured at the interval or ratio scale at the sample are selected independently. So we also use F distribution because comparison between several population means simultaneously and the data was in least interval scale. For the output for this project, we has been identified the null and the alternative hypothesis of two testing by comparing the mean of buses are equal or not. We assume that HO is the mean of buses all is equal. Meanwhile, the HA is mean of buses are not equal. So for the result in the day 1, show that F ratio is 9.02 is greater than F critical, F value 3.32. Then we reject HO, then we accept the HA, which state the population mean are not equal. After that, for the result for day 2, shows that F ratio is 7.18 is greater than F critical or F value 3.32. Then we reject the HO and accept the HA, which state the population means are not equal. As to conclude this result, both of the null for day 1 and day 2 has been rejected and accept the alternative hypothesis indicate that population means for buses are not equal.
Hi, the conclusion is the purpose of the study is to determine that the bus arrive at the bus stop ATM based on the schedule that has been given to the bus driver. So as we can conclude that the first day for our data taken is higher than the second day, which is first day number of bus is 161 and the second day number of bus is 160, and the mean average for first day is 12.45, and the second day the mean average is 12.32. That has been affect the buses. Thank you.